Hello, this is Dr. E. I'm going to be talking about section 8.2, Human Impacts on Ecosystems. The learning objective here is to describe the impacts of human activities on aquatic ecosystems, such as indicating the range of tolerance, coral reefs, oil spills, and what they have done. The suggested skill here is to apply appropriate mathematical relationships to solve a problem, making sure that you show your work. You don't show your work, you won't get credit. So range of tolerance, what does that mean? Organisms have a range of tolerance for abiotic conditions in their habitat. For example, what is the pH, temperature, salinity? Is it sunlight too bright or too dim? The nutrient levels. Organisms also have a range of tolerance for pollutants that human activities release. For example, pollutants cause physiological stress such as limited growth, limited reproductive function, difficult breathing or possibly suffocating, hormonal disruption, death if the concentration is too high. A big theme of Unit 8 is being able to explain specific effects of specific pollutants, hopefully on specific organisms. So what's the environmental effects of acid rain? Aquatic species have different pH tolerances, ranging from acidic 7.5 down to fairly basic, fairly acidic 4.0. So there's a pH tolerance. As pH decreases, becomes more acidic, it becomes outside the optimal range for a species, the population declines. So for the crustaceans here, if it goes below 5.8, it's going to cause problems. When pH leaves the range, they cannot survive at all due to sometimes aluminum will increase with more acidity, causing death. It disrupts their blood osmolarity, which means the sodium chloride balance. It affects coral growth by reducing skeletal density. Indicator species can be surveyed and used to determine the conditions of an ecosystem, for example, the soil, water, for example, the whiteness and of this algae. So the high white moss algae right here indicates that there's a problem at 6.0. Anything below 6.0, they start dying off. Temperature tolerance of reef algae. Coral reef have a mutualistic relationship between the coral and a photosynthetic algae called zooxanthellae. The algae supply the food and the coral supplies the home. There's also decomposing happening due to the decomposition. Algae have a very narrow range of temperature tolerance and leave the reef when the temperature gets too high. So the algae are fairly concentrated here, but when it's becoming warmer and warmer and warmer, the algae die and leave. Pollutants from runoff, such as sediment, pesticides, and sunscreen, so don't wear too much sunscreen or wear the correct ones, can also force the algae to leave. Coral lose their color and become stressed, vulnerable to disease without the algae, which is their main food source. That's why when the algae leave, it turns white, and that's why it's called bleaching. Human impacts on coral reef. We can disrupt the coral reef via greenhouse gas emissions, which warm the ocean temperature and bleach the coral. For example, warming causes thermal stress, which means the algae leave. Overfishing causes fish populations in coral and reef ecosystems, and bottom trawling can completely destroy the reef in this area. Urban agricultural runoff also damage coral because of too much or too little or too much turbidity. Sediment pollution carried into the ocean by runoff makes the coral waters more turbid, meaning you can't see through it. Can't see through it, there's going to be less sunlight, the algae is going to die, meaning there won't be any photosynthesis available because the sunlight cannot get down. There can be toxins, chemicals in the sunscreen, oil from roadways, pesticides from agricultural runoff can kill the fish and or the coral reefs. Sometimes in a here we will see that stormwater runoff, deforestation, oil and chemical spills, road construction, agriculture, all will lead to chemicals. Coastal development, meaning there will be impervious systems so the water will not go down, it just runs off. Chemicals from sunscreen, failed septic systems, all release chemicals that will cause problems to not just the coral reef, but the fish that live there. Oil spill effects. Hydrocarbons in crude oil, petroleum, are toxic to many organisms and can kill them, especially if they eat the oil or ingest it through gills or skin. Other physiological effects: decreased visibility, decreased photosynthesis due to less sunlight penetrating the water surface. Oil sticking to the bird feathers, meaning they cannot survive. Oil sinking to the bottom and killing bottom dwellers due to direct toxicity or suffocation. There's also, for example, in wetlands, the oil can be degraded and causes reduced productivity. Near seashores, the benthos, if there's too much oil, the sunlight cannot get through. The photic zone, it will reduce the amount of area where the light can get in, meaning a lot of critters will not be able to survive. Top predators will be harmed because of something called biomagnification. The smaller fish will eat it, and as they eat more and more of those, it will cause problems. Oil spill effects. Oil can wash ashore and decrease tourism and revenue and kill fish, decreasing fish industry revenue and hurt restaurants. Would you want to go to a beach that looks like this? Can you imagine being able to fish in this area? Give me a break. Oil can settle deep in root structures of estuary habitats like mangroves or salt marshes. Can be toxic to the salt marsh grasses, killing them and loosening their root structure, leading to coastline erosion. Can remove habitats used by fish and shellfish from breeding grounds. Oil spills can occur when an underwater oil well explodes or blows off, such as the BP Gulf spill that happened about 10-15 years ago, or when a tanker runs into a rock or iceberg and is punctured, which happened up in the Alaska area by something called by a ship called the Exxon Valdez. Cleanup can involve booms, in other words, things on the surface, to contain the spread, and ships that have vacuum tubes to siphon the oil off the surface, or devices to skim it. So this would be the skimming, this would be the burning, but again, you have an area to keep the oil in. Physical removal oil from beaches and sand, rocks with towels, soaps, and shovels. Chemical dispersants sprayed on the oil slicks to break up and sink to the bottom. They can clean up the surface but can smother bottom dwellers. The dispersant chemicals may be harmful. So, practice FRQ 5.2. The Alaskan National Wildlife Refuge on ANWR on Alaska's North Slope is frequently in the news because petroleum geologists estimate that there are billions of barrels of economically recoverable oil beneath the surface of its frozen tundra. According to a 1998 United States Geological Survey, ANWR may contain up to 10 billion barrels of recoverable oil. Oil company officials advocate opening the refuge to oil exploration and the subsequent developing of its petroleum resources. Environmentalists argue that oil exploration and development will damage its fragile ecosystem and urge Congress to protect ANWR by designating it as a wilderness area. The United States uses approximately 20 million barrels of oil per day. According to the USGS estimate, for how many days would the technically recoverable oil be a resource in ANWR supply the total U.S. demand for oil? Thank you, and I hope that was helpful.